Hello, welcome to this lecture on Introduction to Signal Conditioning. Myself, Love Singh, Assistant Professor, School of Mechanical Engineering, Balkotia University. I welcome all of you on this course, that is BTME 3009, CAM and Automation. And today's lecture, we will discuss about the Introduction to Signal Conditioning. The objective of the today's lecture to study the different component of signal conditioning and their function in the mechatronic system. In the signal conditioning process, there is further few steps. First is amplification, then filtering, then isolation and protection, then linearization, then multiplexing, then ADC and DAC process, then modulation and demodulation. Actually, the signal conditioning means the refining of the signal so that the noise and unnecessary components of that signal can be removed, and signal will be in linear fits in the linear curve. Next is the structure of strain gauge. The majority of strain gauge are foil type, available in wide choice of shapes and styles to suit a variety of application. This consists of pattern of resistive foil, which are mounted in backing material. This is the end lobe. This is just one structure of shape gauge. This is active grid length. This one is active grid length. This is end lobe. This is solder circuits. They operate on the principle that as a foil is subjected to stress, the resistance of the foil changes in a defined way. Next is the working of strain gauge. As a Wheatstone bridge circuit is the basic principle for this strain gauge. So if there is change in a resistance proportional to applied strain and measured with Wheatstone bridge method. So this is the strain gauge. In the strain gauge, this is the circuit diagram for that. This is the resistance which are connected in series with this circuit. If there is change in resistance that is applied proportional to applied strain, that then this change in resistance is measured using this Wheatstone bridge circuit. The sensitivity of strain gauge is described in terms of characteristics called gauge factor. This is defined as unit change in resistance per unit change of length. That is, K is equal to unit change in length resistance delta R upon R. That is unit change in resistance divided by unit change in length. That is delta L upon L. The gauge factor is related to Poisson's ratio mu by K is equal to 1 plus 2 mu. Next is the type of strain gauge. The strain gauges are based on principle of working, that is mechanical, electrical, piezoelectric, based on construction, that is foil strain gauge, semiconductor strain gauge, photoelectric strain gauge, based on mounting where they are applied bonded strain gauge, unbonded strain gauge. We will discuss further about these types of strain gauge in the next slide. First is the mechanical strain gauge. It is made up of two separate plastic layers. The bottom layer has a ruled scale on it and the top layer has a red arrow on the pointer. One layer is glued to another side of the crack and another one layer of another. As the crack opens, the layers slide very slowly past one another and the pointers move on the scale. The red crosshairs moves on the scale as the crack widens. Next is the electrical strain gauge. When an electrical wire is stretched within the limit of elasticity such that it does not work, break or permanently deform, it will become narrower and then longer. And changes that increase electrical resistance end to end. The strain can be inferred by measuring change in resistance. Piezoelectric strain gauge. The piezoelectric generates the electric voltage when the strain is applied over it. The strain can be calculated from the voltage and piezoelectric strain gauge are the most sensitive and reliable devices. This is in this diagram you can see this is the piezoelectric strain gauge. Next is the bonded strain gauge. Bonded strain gauge. The bonded strain gauge element consists of a metallic wire. As you can see, this is a metallic wire. In each foils, this is its foil. Vacuum deposit film. The vacuum deposit film is here. Okay, or a semiconductor bar is cemented to strain surface. So this is a diagram for a bonded strain gauge. As we know, if there is this is the small this wire are part of circuit, and then when the strain is applied across this strain gauge, then there is change in the length, and corresponding to their change in length, there will be change in resistance also. So upon change in this resistance can be measured so that strain can be calculated in that particular part. Next is a strain gauge selection criteria. The strain gauges can be selected using a gauge length, number of gauges in gauge pattern, arrangement of gauges in gauge patterns, gauge resistance, temperature sensitivity, carrier materials, gauge width, availability, or cost. The semiconductor devices that are used for signal conditioning are diodes, then bipolar junction transistors, thyristor, insulated gate bipolar transistors, static induction transistors, then metallic oxide semiconductor field effect transistors. These are the devices that is semiconductor devices which are used for signal conditioning purpose. This is a PN junction diode that is forward bias PN junction diode circuit. This is PNN junctions where this is negative ion, this is positive ion, and there is a minority carriers it moves towards this P type and majority carriers moves with N type. And this is metal strips. This is our power source, that is voltage difference applied across this system, and this is representation. Here is the representation, that is anode as moves toward cathode, and there is a short circuit that is forward bias, that is positive moves towards the negative, and this is P junction PN junction diode characteristics, that this is shown in this diagram. Next is the bipolar junction transistors. All the three types semiconductor device transistors, for example BJT, field effect transistors FET, and junction field effect transistor, that is JFETs, and MOSFETs, etc. And bipolar junction transistor, a transistor is either P type or NPN type. The transistors are used as a switching device in a situation region for low voltage and low circuit current applications. The modern transistors being fast are suitable for very high frequency switching operation. The four classes of transistors are BJT, MOSFETs, SIT, and IGBT are used in amplifiers, oscillator circuits, computers, satellites, and modern digital communication. This is the operating mode for the BJT transistors. The biasing mode of a transistor result in operation of transistors and their operation characteristics. The mode 1, it's in the saturation, both the electron bond and energy bond, and CB forward bias, and then in the mode 2, in the cutoff, the both EB and CB reverse bias. In the mode 3, in the active mode, the CB reverse bias and EB forward bias. In the mode 4, in the inverse mode, the CB forward bias and EB reverse bias. In mode 1 and 2 are used for switching, and mode 3 for amplifier actions. However, mode 4 is not in operations. Bipolar junction transistors, that is, this is operating mode. This is transistor biasing CB configuration. This is a CP configuration here. The P and N types are there. This is the forward bias. This is the reverse bias. This IE and this is IC. This is transistor characteristics and configuration. That is input characteristics CV configuration. This diagram shows this operating mode. Next is FET. The majority carrier flows in a device. This is type N channels and P channel. The FET terminal as compared to the BJT emitter is called the source and Y is the gate, the collector the drain. The four-layer devices are used for high power application and fast switching. The type silicon controlled rectifiers and diode for altering currents and tridiode for altering currents, that is TR, IAC, etc. The thyristor's equivalent to the combination of two back-to-back transistor connection, and the terminal is anode is A and cathode is K and gate is G. This is the home assignment for all of you. You have to submit this assignment before the next class. These are the reference from where this all the image and this data is taken. Thank you.